So let's do this. So this was your mock test. Are you all able to see the mock test?
Yeah.
Right.
Were we already supposed to have had this, or did you give this out when we were on Kairos?
Um, you, as in, did you about sitting the test, or as in the graded copy?
Um, have we did we do this in class together? I just can't remember.
Well, you took this test. We haven't had a chance to go over this.
Oh, okay.
Yeah, you
Okay,
already
yeah.
took this test way back, and then not way back about 2 weeks ago, 3 weeks ago, I believe. Yeah, 3 weeks ago. Um, and then I've graded it, but you just don't have the copy with you.
Gotcha.
Yeah,
I remember the Archie and Gary now.
yeah, right. So let's start with question number one. So question one was quite simple, I believe. It was that you've got a dog who's going to run after a squirrel. Part A was asking, well, what was Archie's acceleration? So let's go here, and you've got question one solution. So part A was asking, well, what is the acceleration for Archie? Uh, it gave you that it took Archie 5 seconds to reach his top speed of 3 meters per second, starting from rest. So you could use equation one from equations of motion. So Vf is equal to Vi plus AT or delta T. And then you could rearrange this equation to find basically Vf minus Vi divided by your delta T to get the acceleration. So that's going to be 3 minus 0 divided by 5 or zero point 0.6 meters per second squared. That was the answer to part A for Archie's acceleration. Part two of the question, and please stop me while I'm going over this. If something doesn't make sense to you or you want to ask a question, I cannot see your screens anymore or your any chat messages while I'm going over this. So you'll have to kind of unmute yourself and then speak up.
Did you share this Jamboard with us?
I haven't shared the Jamboard with you, but I will after the recording's finished. And then this video will be posted on YouTube, so you'll have everything there on the YouTube as well as a video solution, right? So part B was asking you, well, how much distance did Archie cover in the first 5 seconds? So part B is, well, you're looking for the distance. So you can use equation number two to find the distance. The equation two from equations of motion. So Vi delta t plus half a delta t squared, right? So our initial velocity is 0. Delta t is 5 seconds plus half times the acceleration that you just found, zero point 0.6 times 5 squared. Or if you're to solve this, you would get, I believe the answer was zero point 0.5, 7.5 meters, right? And then part C was asking you for, well, if Archie continues to travel at the constant velocity of 3 meters per second. So the trick here was to know that this is a constant velocity. There's no acceleration. How long will it take him to reach Gary the squirrel? So there are two ways to solve this. You could do, uh, well, you could do the remaining distance. So delta x remaining would be 20. So the 20 was the total distance, 20 minus 7.5 meters, and you'd get 12.5 meters, right? And again, using second equation of motion, so delta x is equal to Vi delta t plus half a delta t squared. You could solve for it. Now, in this case, this is 12.5 meters. Our initial velocity is 3 meters per second, or the velocity that Archie reached for this distance right here. Delta t is something that we're looking for, plus half. Since it's a constant velocity, acceleration is 0 meters per second squared, and delta t is something we're looking for. Since this is 0, this cancels out, and this becomes 0. And all you're left with is Well, 12.5 is equal to 3 delta t. Or delta t is equal to 12.5 divided by 3, and that would have given you 4.17 seconds. And I believe that was your answer. Or you could add it, sorry. So that was the answer for the 12.5 meters, and the total time was 5 seconds. So the initial one to reach the top speed plus 4.17, or 9.17 seconds. That's the total time taken by Archie to reach Gary. Any questions with question number 1? No? Okay, I'm assuming the answer is no. Again, you'll have to speak up.
Did.
Okay. Question number 2 was that as soon as Archie reached or neared Gary, Gary leapt and climbed up a 25-meter tree while carrying the acorn in its mouth. So Gary was accelerating constantly at a net rate of 2 meters per second squared while starting with an initial upward velocity of 5 meters per second. How long did it take Gary to reach to the top of the tree? So we're looking for time here. Now, in this case, what you can do is for question number 2 then, there are 2 ways to solve it. One way is to use the second equation, delta x is equal to vi delta t plus half a delta t squared. Now the tree is 25 meters tall. You've got vi, which is 5 meters per second. Delta t is something that we're trying to solve. And half 2 times delta t squared. So 25, 5 delta t plus delta t squared. Or you could rewrite this equation and you could get delta t squared plus 5 delta t minus 25 is equal to 0. And you could solve this using your quadratic equation. So delta t is equal to minus b plus minus under the radical b squared minus 4ac over 2a, and then a is equal to 1, b is equal to 5, and then this would become your c. Right, and if you were to solve this, what you would get is, let me just do it quickly on my calculator here. So I've got 1, 5, and negative 25. And the answer is either 3.09 seconds. The second way to do it would have been to find, well, what the final velocity is, and then find the time. So you could use the first equation, vi plus a delta t. But in order to use this to find delta t, you first need to find vf, which you can find from the third equation of motion. So vf squared is equal to vi squared plus 2a delta x. So vf is equal to, well, 5 squared plus 2 times 25, and that entire thing can be put under the radical. So we've got 25 plus 100, or under the root, and that would give you 125 under the radical, which is going to be equal to root 125 gives you 11.18 meters per second. And then you could use this equation right here to find what delta t is. So 11.18 is equal to 5 plus 2 delta t, or delta t is equal to 11.18 minus 5 divided by 2. And the answer would be 3.09 seconds. So either of the methods were correct. Question number 3 was asking for, well, if I recall correctly, what is the total acceleration against the pull of gravity? So remember, this is a balance of forces again. So if this is your squirrel, you've got some acceleration here, A, You've got pull of gravity here, which is 9.81 meters per second squared. So your A net is, well, your A up minus A down, right? Or this is equal to 2. So your net acceleration was 2 from the previous question. A up minus 9.81, or A up is equal to 2 plus 9.81, or in other words, 11.81 meters per second squared. Right? Any questions so far? Nope. Then moving on to question number 4. Question 4 was asking you that while Archie is running towards Gary with a constant velocity, what are some of the forces acting on Archie? So it's looking for a free body diagram. So again, free body diagram is a single dot or representation of the object with a single point mass. So you've got your forward force, and you've got your resistive forces, you've got your weight, and then you've got a supporting force from the ground or your normal force. Right? And resistive forces are essentially your air drag plus friction. Okay, and that would have gotten you, I believe this was for 5 points. Yeah. Next part was to do with, well, Jesse, who's the owner of Archie, was trying to push a 50-kilogram crate while Archie was going after Gary. What is the weight of the crate? So question number 5, part A, well, weight is equal to mg, and 50 times 9.81 should get you the correct answer. So I believe the answer was 490 something. 490.5 newtons. Part B was asking you for, well, it took Jesse a force of 200 newtons to get the crate moving. What is the coefficient of static friction? So remember, static friction was what? The force required to move the object from rest. If you recall your lab, divided by the weight, or 200 divided by 490.5. So your answer is 0.041. Part C is asking you for that if the coefficient of kinetic friction is 0.15 less than the coefficient of static friction, what is the force required to keep the crate moving at a constant velocity? So again, same thing. Kinetic friction coefficient is 0.5 less than the static friction coefficient, so 0.41 minus minus 0.15, and that should give you 0.26 as the coefficient of static friction, or kinetic friction. And then the formula was kinetic, it's the same formula, so force applied or required divided by the weight, and that should give you that your force required or applied is 0.26 times 490.5 times 490.5 and 126.43 newtons.
Is it 0.41 or 0.04
Where?
for the coefficient of the static friction?
So right here?
Yeah.
No, that should be 0.41, not 0.04.
Oh,
Yeah, it's 200 divided by 490.5.
okay.
Yeah, so it's the force required, the force being given to you in the question. We found the weight in our part A. So 490 is your weight, and this is the force that is required to move the crate in the first place. So 200 divided by 490.5 should give you 0.41,
Okay.
right? Any questions with this so far? No?
No, we're good.
Okay. So we've done part C. Now part D is asking what is the frictional force acting on the crate while it's being moved at a constant velocity. So again, part D is we're talking about constant velocity then. So what does constant velocity tell you? That you've got this force, let's say forward force or applied force, and you've got frictional force on acting opposite to the crate. Now, if you're moving at a constant velocity, that means that your acceleration is equal to, or a net is equal to 0 meters per second squared on the object. And that means that since F is equal to ma, so your F net would be equal to ma net. Since a net is equal to 0, your total difference between these two forces right here is going to be 0 newtons. So F forward is equal to F friction. And that means your F friction is the answer to part C. 126.43 newtons, as we've done here. Right? Any questions with this? If not, let's start with question number 6 then. So you've got Archie's resting under the tree, waiting for Gary, the squirrel, to return. In order to distract Archie, Jesse lobs a ball at Archie. The total horizontal distance between Jesse and Archie is 25 meters. With what velocity should Jesse launch the ball such that the ball just boops Archie's nose? So question number 6 then is that you've been given your delta x, which is 25 meters, right? And the angle was 50 degrees. So your launch angle is 50 degrees. And since there is no height difference, that the launch height and Archie's nose are at the same height, your difference between the launch height and the receiving or the crash height are the same, so that is equal to 0 meters. So now we're looking for, we're essentially trying to solve for the initial launch velocity. Now, if you recall from your projectile motion equations, delta x is equal to vi x delta t total. Now, delta t total is what? Delta t total is the sum of delta t up time plus delta t down time. And if you go through your equations of projectile motion, let me pull those up on my other computer here. I believe delta t up was given as, delta t up is equal to vi by g. So you've got vix, vi divided by g plus delta t down. And then delta t down, on the other hand, was, so we substituted for delta t up over here, and then plus delta t down. Delta t down then is your formula sheet is available to you on your classroom as well. Then in order to find delta t down, we first needed to find delta y up, and that delta y up is given as, vi y squared 2g, right? This is in the up direction. And then delta y down is, since there's no difference, your delta y down is equal to delta y up plus z. since this is equal to 0, you've got VIY squared by 2G, and then delta T down is quite simply delta Y down times 2 divided by G under the radical. So if you just take this equation right here and write it on the next page, so your delta X is equal to VIX times VIY by G plus delta T down, which is 2 delta Y down by G under the radical. Now delta Y down is VIY squared by 2G. So you could write it as VIX VIY G plus 2 times, or 2 by G times VIY squared by 2G under the radical. 2 and 2 would cancel out, and you would get VIX is equal to VIY by G plus VIY squared by G squared under the radical. And this could be rewritten as, well, essentially delta X is equal to VIX VIY by G plus VIY by G again here, and you would get something as VIX 2 VIY G, or 2 by G VIX VIY, and VIX and VIY are velocity components, so 2 by G VI cosine theta and VI sine theta, or delta X is equal to 2 by G VI squared sine theta cosine theta. Now in this case, you're able to solve for VI squared, or VI would be equal to delta X times G divided by 2, or sine theta cosine theta, or VI is equal to delta X G by 2 sine theta cosine theta under the radical. And now if you were to put in all the values together, so you've got 25 meters times 9.81, 2 sine of 50 cosine of 50 under the radical, you should get your answer. And that answer was equal to cosine 50, good answer, 15.78 meters per second. Right, that's your answer, or that should be the launch velocity. Now the second part was, well, with what y velocity will the ball impact Archie's nose? And part B could be then, well, we're just looking for VFY. And if you go through your equation sheet, VFY squared is given as 2G delta Y down, or you could use VFY is equal to G delta T down. Right, and then delta T down from your a couple of pages earlier is given as, well, 2, or that's equal to VIY by G right here. Right, VIY by G, because our initial heights are the same. So then VFI is essentially equal to G times VIY by G. G and G would cancel out. It's equal to VIY, or VI sine of theta, and VI was, as you found out, 15.68 times sine of 50, and that would give you, sorry, 15.78. not 6.8, 7.8. Yep. Times sine of 50, and that's equal to 12.09 meters per second. And that's your solution to the entire mock test. Now, since this was an open book test, you could have used this equation right here, this one, this equation right here, and solve for the time, or sorry, the initial launch velocity, and that was fine too. You didn't really have to go through this entire process, but I wanted you to see how we got to this equation again, or at least one more time. Any questions?